I'm Simon St. Laurent, Strategic Content Director at O'Reilly. I'm here with Mike Amundsen, who's written several books for us and is traveling the world to discuss hypermedia. So I think of you as the traveling apostle of hypermedia. At least I keep seeing you at shows. How's that been? How's that message getting out?
Well, that's actually... it's very interesting. I sense it's changing this year. So you're right. I mean, for about the last 5 years, you and I have been talking about this for a long time, right?
Yeah.
For about the last 5 years, I've really been pressing this notion of using this particular technique for applications, and not just for the web, but actually for business. And so starting around 2010, I started publishing material. We finished the first book on designing hypermedia APIs in 2011. And now that there are a couple of more projects out, it turns out there's not a day that doesn't go by when somebody doesn't talk to me about hypermedia. Perfect. Of course, that's a little self-selecting. But one of the things that I found most interesting is enterprise analyst types are actually now talking about hypermedia. In fact, I just recently read an article that basically said microservices will get it right if and when they start using hypermedia. So I think people are starting to talk about this more, and that sort of changes the way I talk about it. I spent the first couple of years mentioning the name, just to kind of create that. I spent the next year or so explaining what it was. Starting this year, I'm actually showing code. So now we're really focusing on, how do you do it? There's no more question about what it is, and that's been very, very exciting. So there's a lot of code.
For those folks who may not know what it is, let's sort of talk about the path. Like, I remember when I was first getting into web services, I will confess that I wrote a book on XML RPC. There was this whole SOAP revolution that was going to change the world, and UDDI would be making everything findable, and that all kind of faded. And then we got to REST, and there are much deeper roots to this. I feel like we're just reinventing things, but sort of, how do you describe the current path? How did we get here?
Yeah, so I think what's happened is, I had a conversation with somebody a couple weeks ago. The aspirations over the last several decades haven't changed. We want to automate more, build more resilient systems that can adapt and last a long time, survive change, and so on and so forth. So that's not changed. But the technology that we're using to attempt it has. So we pretty much remember the SOAP, what we call the SOAP era, right? The aughts. Of course, there were a lot of stuff before that. So you could go all the way back to Alan Kay and Smalltalk and all these other things where Alan was talking about extreme late binding. He's got several pieces where he talks about that. And he wants to create a world where I can deliver something, and then a few months later, having learned something really important, go back and change something that I started with and do that in real time without affecting anything. So he's talking about this in the 70s and 80s. That's part of what Smalltalk was about. And he did it sort of on that machine level, right? So we've definitely gone through this a couple of different times. I recently wrote a piece for an online magazine that compared Alan Kay's message model. He always said he regretted calling it object-oriented, that he should have referred to it as message-oriented. Of course, he wasn't the only one talking about it at that time. Nygaard was the other person in Scandinavia. But we've gone, where I compare his message-oriented with Fielding's network-oriented writing, like Fielding's architecture, Fielding's known for REST and all these other things. They're separated by close to 20 years. But they're talking about almost the exact same thing.
Sort of over a broader scale.
Exactly right. So I think that's the thing that we're seeing. So nowadays, the phraseology we're using that talks about distributed systems over a network is now being called microservices. Which is really talking about some of the same things. Small things, one thing that does one thing well, that's the McElroy Unix model, and things that you can put in place and connect later. So I think there's a lot of that going on. And hypermedia is just a technique that you can build into products, build into components, build into your network that allows some of that to happen.
It lets that late binding happen in particular.
Yes, so that's the whole point, right? So I'm not binding to a function and a signature. I'm binding to a message and a port. When you really think about HTTP, it's a port and a message. That's really it. There's a magic phrase. It's the very first line of that message. That's GET or PUT or POST. That's like magic power in the first line, but it's a line, it's a collection of name-value pairs, it's a space, and then it's possibly a body. Then it's all a message sent to a port. So even when you look at thrift or buffer, all these other things that we've done in the last 5 or 6 years, these are messages. These are attempts to put messages in a bottle and send them, right? So we're all kind of dancing around the same thing. I think we're going to get closer with this round, and I'm excited. And I think part of it is because we're starting to see that the message isn't just the data, it's also what you can do, and that's really what hypermedia is about.
This mention of a round, things kind of keep cycling, and this has been the great story I've seen in computing. Well, I guess I got into computing in like 1981, and by then everything interesting had been invented, and we've just been going kind of forward in different directions. We changed the variables of openness, of granularity, of what kinds of things we're sending around. Like just sending photos seemed impossible until fairly recently, and now it's completely normal.
Yeah.
But as the scale and the scope change, the underlying architecture I don't think changes very much, but the conversations around it all seem to get tangled. We expect everything to be new somehow.
Yeah, I think that's partly true. I think another part of it goes back to the conversation I had about aspirations versus tech, right? So often what we tangle is the ideas with the tech we have. Like when I have a smartphone, then it seems to me that the smartphone is ruling everything, right? Because I have it all the time. So that's what we talk about, mobile first, and mobile's driving innovation, and so on and so forth, because I have a smartphone. If I had something else, maybe I would start to think that's my sort of confirmation bias, that we used to think the desktop was driving everything, right? So I think we're still trying to get the same path, trying to do the same things. You talk about rounds, and like doing it over and over again. One of the other things that we're talking about in this microservice space is this notion of a thing called Conway's Law, or Conway's adage, that the output that you get is actually a match to the way you organize your communications between your team. Eric S. Raymond, a great open source guy, explained it this way. If you're trying to build a compiler, because that's what you would be doing in the 80s, we built lots of compilers, trying to build a compiler and you have 4 teams building it, you're going to get a 4-pass compiler. If you had 3 teams, you'd get a 3-pass compiler, right? So now we're talking about this Conway's Law again. Conway published this in 1968. He published it almost around the exact same time, I think within a matter of months, of the mother of all demos by Douglas Engelbart, who introduces the mouse and introduces collaboration and on-screen video and shared cursors. So yeah, I mean, we do kind of go round and around and around on this. What's I find really interesting is Melvin Conway, Conway's Law, that article actually has about 4 adages, which I'll be talking about at the Velocity Conference in Amsterdam later this year. And Melvin Conway is alive and kicking and has working on lots of really, really cool stuff around this notion of empowering individuals to create something that's very close to their everyday lives. He's a great guy. He's living in Boston and still talking about lots and lots of very cool things. He's actually asking questions right now about APIs.
Okay.
He's just recently talked to me. He says, well, we need to talk about more about APIs. So not only are we going around and around, some of those same great minds are still with us. Alan Kay, of course, is still around. So we have lots and lots of opportunity to expand on this, to actually not just revisit, but also expand on this great thinking.
Well, the APIs piece is interesting because I'm seeing it. I mean, I first really encountered it in sort of a web or an XML context, that kind of thing. We're seeing APIs extending to things that we do in our ordinary lives. There are all of these devices around us, not just the smartphones, but simpler things that have APIs.
Yeah.
And when the scope and the scale is changing, we think about data centers when we think about scale, but we also should be thinking about the tiny gadgets powering drones and cameras and whatever.
Yes, I think that's actually, again, one of the things we learn, right? Scale isn't just a larger and larger building. Often it's a set of buildings. It's a community.
Right.
And I think one of the things we're starting to discover with smartphones and watches and other smaller devices is the challenge isn't programming the watch or programming the phone or programming the machine. The challenge is programming the network.
The whole
right? So when Fielding wrote his REST dissertation, he actually has a chapter in the end nobody reads. He wrote his dissertation about network applications and network architecture. And REST is just one chapter. The last chapter is the challenge of network APIs, the challenge of getting networks to work together rather than one machine. We don't have a good programming language for the network. It's because it's like lots of different machines. We don't have a good model for the network. We don't have a good visualization for the network. So all these things we want to do right now are starting to converge on the notion of how do I get networks to work. I think that's why we have containers. That's why we have container management. That's why we have all these other sort of new initiatives around this space, because now we realize it's above the machine. It's not just what's running on the machine, it's how the machines talk to each other. So I think that's also a really, really big part of this.
Well, there is a brittleness that sometimes sets in when you have large sets of things talking to each other. People become very afraid of breaking what already works. And, when I think of the hardware thing, one of the things that's intriguing to me is that a lot of them don't really have an upgrade capability. Some of them do. You can upgrade a certain level of them, but others are like permanently out there. We also talk, like even in the data center, of putting up services that are immutable, or this container, we're not going to change it. And I'm suddenly seeing things that I thought of in language design, like the crazy things I learned from Erlang about lightweight processes and not changing your data as it's coming and going, turning up at a higher level. And so I think it's much more than just my fun with Erlang. It's things that we learned in programming languages are growing outward and reaching whole new heights and having to deal with a wide variety of things. Whereas when I was just starting out, I wrote everything as tightly together as possible. All these things that were really strictly part of my control space are now no longer in my control, even as I have more general power.
Yes, actually, that's a really good observation. So you really just kind of talked about the difference between I used to think I was in control. I used to be in control of all the aspects. What's happening as we're doing things on more than one device, I don't control those other devices anymore, right? And so immutability becomes, it looks like it's like a burden, right? So this idea that, well, I can't change that, so maybe that's no use to me anymore, or changing that is incredibly dangerous. That's one of the things that happens in immutability, right? When you break that law. So in APIs, we actually invent a whole ceremony around this change, and we call it versioning, right? We say we're going to create this big ceremony that tells everyone, in the known universe that this thing has changed in some fundamental way, in hopes that everyone else will just change with it, right? But that's not how nature really works, right? That's not how systems work. What happens is things don't necessarily, change. What happens is they get replaced, or what happens is you bind to things that are less likely to change in order to cut down on the danger and cost of immutability. One of the great things about microservices is this notion that there are all these things that I could sort of plug together somehow, but that means I don't integrate. It means I interoperate. You talk about history. There's a gentleman that sort of came up with this idea, and his name is escaping me at the moment. Maybe you can help me. It was called the alien problem in the 60s. Somebody else is reading this. We'll remember the person who came up with this. How do we get computers who've never met each other to talk? What's going to happen in some future? This was in the 1960s when they were trying to figure out, well, maybe we'll see aliens, right? So what we're going to do, he said, is we're going to probe each other. We're going to test each other and see if we can find common ground. This is how interoperability works. This is why systems like HTTP actually have content negotiation systems. Just talked to somebody yesterday who was talking about the idea of vocabulary negotiation, like we can negotiate the dictionary we're using while we're talking. So what happens is we find as we have more machines, we have to create more loosely coupled or loosely bound interoperabilities, and there's a cost of overhead to kind of learn how you talk and how I talk and how this conversation is going to go. That's sort of a built-in feature in the beginning of this stuff. And that overhead is actually how we work as humans. That's how we learn to talk to each other. It's how I meet someone. We have these ceremonies about greeting and saying hello and so on, finding out what languages there are. So this whole set of overhead has actually also been discussed in social circles by a person by the name of Robin Dunbar. You probably know Dunbar's Law, Dunbar's number. Dunbar's number is 150 friends. Like that's sort of the maximum number of people I can keep very close track of. He noticed in social circles that when you have about 150 friends you're trying to all keep track of, about 40% of your conversation is overhead. It's just maintaining relationships, keeping in track of everybody. What are you doing now? So on and so forth. When you think about interoperating software, you've got overhead. I actually think Dunbar's law, social law, 5 is intimates, 10 to 15 is family, 35 to 50 is tribe, 150 is friends. Right. There's a 500 and 1500. I think the Dunbar's law may actually start to teach us about dependencies. If you have too many dependencies, you've got a huge amount of overhead when you're trying to maintain software. So I think there are all sorts of things, and Dunbar's law is why squads of 5 people, a two-pizza team, works really, really well, because in Dunbar's case, those are intimates. There are all sorts of conversation that you don't have to explain to each other. You just sort of know how they work. Right. We all experience this. As you get a larger and larger group, then you have more and more communication overhead. So all this stuff is coming from 50 years ago or more, but it's coming back over and over again, and it gives us a chance to apply to new technology. Same ideas to new technology.
Well, these are things that we understand when we're talking to humans. Naturally. Yes. But we've spent so long treating computers as very different from humans. The early programming languages were all about making the computers just tractable to humans.
Yes.
We have a wide variety of efforts to make that work better. And I'm thinking we're seeing it here in the cultural story. We have programmers who were raised, you're going to get this right, you're going to know this about the microprocessor or whatever you're working with. And how do we convert the culture from expectations that were formed when computers were the center of the world to these larger social expectations as networks are the center of the world?
So I think that's really good. So again, that's a cycle that's been going on for a long time too, right? If you just, if I jump the shark and I say the words AI, right?
Right.
So AI's been, a promising thing for decades, for generations. We're this close. We're this close. We're this close. We're always this close. And I think there's some great stuff that we can learn from that experience. Douglas Hofstadter, based at Indiana University, wrote this book called Gödel, Escher, Brock, and he was very early in this AI space, and he had this notion that what we need to be focusing on is the way the human brain works, not facts or statistics. Mm-hmm. Whereas Google and IBM Watson and they have been able to monetize a lot of statistical work, that tends to have a dead end, right? So there's a long history, but I think it's a history that doesn't get a lot of play. So Hofstadter's been at this for 30 or 40 years. There's a big group out in Santa Fe, it's called the Santa Fe Institute, which talks about treating this more like the way the brain works rather than the way statistics work. There's a person based right here, Melanie Mitchell, and teaches at university here, and I can't remember which one it is, but she's got this fantastic set of books on complexity and study on complexity that are really sort of a hallmark. She does some work at the Santa Fe Institute of this other leg of the story. And what I think I see happening when I talk to people in their 20s, young people just coming in, they don't necessarily have a perfect trust of a computer.
Yes, they've learned.
So they're more interested in how can I create a computer that will do what I want without screwing something up. They sort of have this resiliency and safety stuff built in. All this stuff we learned from the space program and from the nuclear program about resiliency and safety, and you can't avoid mistakes, but you can prepare for them and protect for them, is starting to leak into software as well. I think what we're going to be building autonomous software that is at first safe, right, and second enabled, right? And I think we're going to start building those things. That's actually where I think we're headed, and that's a very different area than what I was taught, right? I was taught a very deterministic, like you say, tractable kind of experience. So I think there's technologies now to talk about enabling machines to do things safely, and I think that's a very interesting space.
And what kind of responses are you getting? I mean, the generational thing I think is there. Some of the things I'm talking about definitely apply to people my age. Younger is different, older is different. Yeah. Enterprise culture is kind of my classic summary of people who want all of these things to be neatly wrapped up and hopefully stable. And in some ways, what you're proposing seems like a radical departure. These things will be flexible and all of this. Yep. On the other hand, the resilience doesn't come any other way. Right. So how is that message going over?
Well, so I think it's definitely, we talked earlier about how do I feel about the idea of hypermedia. Hypermedia is now, people come to me and talk about it, right? So it seems to be a standard thing. This this notion of self-reliant or resilient safe systems is now sort of the next, oh, you're just being crazy now kind of talk, right?
Right.
So there's definitely, when I start to talk about this, people say, yeah, maybe. I've done a series of sort of keynote-style talks, which actually reach back to von Neumann machines and all sorts of other things, stuff from the space program. You know, Ted Nelson talked about these kinds of things all the time.
Right.
So I definitely, people find it entertaining, but they're always like, yeah. Who was it? Yesterday we had a keynoter who talked about the future. Like
Paul Fenwick.
Yeah, Paul Fenwick. Paul Fenwick's always a great speaker. So Paul talked about this idea of like what happens in the future, and we always kind of tend to think that future is that'll never happen, the thing that we're talking about. But if you think about it far enough away, suddenly you realize, oh yeah, I guess it could. Now I'm challenged with having to think about it. Right. So I think that's what happens. People have to be challenged to think about it a little bit more, and the more they do, I think the more we're seeing the culture shift, like you mentioned, and that will start to reflect back into the technology. Sam Ramsey of Cloud Foundry talked about that today. That the companies have to recognize the culture shift, and they need to shift their technology to match it. Otherwise, they end up in the losing column, and I think that's what's going on.
Right. I think about some of the first times I saw you speaking, I was kind of expecting you to bring a unicorn on stage because I mean these things are totally appealing to me, but how do we get there?
Yeah.
And I remember being blown away when like 25 people showed up for a hypermedia buff late at night.
Yeah.
And like this is the sign that it's starting to get here.
Yeah.
Maybe
I think also it's important to realize that hypermedia is a technique, it's a representation of the aspiration. Goes back to what we talked about before. We have the same aspirations, we get different technology through all time. So hypermedia isn't the answer, it's an answer, right? And really, I think if we think about sort of the meta of that, the idea that what you want to do is not just include data, but also actions, activities, treat it like an environment, a real place. Then all of a sudden the idea of creating an autonomous machine that can navigate an environment and find the affordances it needs to get its job done doesn't sound so wacky anymore. It's not so science fiction Hollywood. And then pretty soon you start to think about how you can actually physically build one of those. I did a talk on Oslo just last month where I showed how to build client applications like user-facing UI clients that adapt based on message, on hypermedia message. And that's part of a book project I'm working on, as you know. And the second part of that book is actually how to build components that adapt, not UI, but actually components that adapt in the exact same way. So suddenly, it's just a little bit more of a step. It's not a big leap anymore. That's like so many other things. This sort of the story about the straw that breaks the camel's back. You think it's just that one straw, that one thing that made it all happen, but of course it's not. It's decades and decades of really creative thinking and people working on all sorts of bits and pieces. And I think that's what we're seeing a lot of.
The pile builds, and finally there's a great avalanche.
Yeah, and then suddenly people say things like, good ideas. I forget who the philosopher was. Good ideas. At first they're ridiculous. Second, they're rejected or argued against, and third, they're like, "Oh yeah, of course."
Right. I like this story better than the traditional hype curve story. It's a little more exciting.
Yeah, because I think also it goes back to that notion of really we're doing the same kinds of things that we've done for decades. That's what a lot of us oldsters tell the kids, like, "Oh, you kids, I remember back in the day when I was, writing on my stone tablet and bit code and." But we're doing the same kinds of things, but we have new technology. And we'll have even newer technology in 15 or 20 years from now. So it's a matter of thinking about what it is we're trying to do and employ whatever we have on hand to get there, I think.
Cool. Well, hopefully this will bring us resilient flexibility.
I'm sure it will someday.
Thank you very much, Mike.
Thank you.